right? And Ron has proven, without a shadow of a doubt, a little bitty generator driving a motor 5 times its size.
That's correct.
And speeding up while doing it.
Did you do that, Ron? Are you still there, Ron? Oh, Ron, you're there. I just didn't have you punched in. Go ahead.
Oh, okay, I'm here now. Yes, I have done what John mentioned.
But tell him, Ron, tell him about the little bitty wires. And you see, I want to throw this into the program because the motor that they are looking at is what our science calls believing.
Okay, well, let me give an explanation of the itty-bitty wires, as you mentioned.
Can you hold on that explanation, Ron?
Yes, I can.
You understand this as much as anybody, but I have to take a little break here before we get to the little bitty wires, smaller than your hair, that shouldn't do what they're doing.
All right.
Isn't that true?
Yes, that's true.
All right, hang in there. I'm Bill Jenkins. It's Open Mind on KABC. Harris here.
Okay, I try to give a illustration of this in a somewhat simplex form so some listeners can understand. In electrical flow, basic circuits based on conventional engineering design, current and voltage oppose each other. They flow in virtually opposite directions. And this goes back to as far as Steinmetz's basic engineering book still taught in the college today by Mr. Cook and so on and so forth. Point being that the voltage is equivalent to the value or quantity of what is to be used, such as water. Current is how much water do you have. What is the mass of the water? Okay. Well, in electrical circuit, these two factors end up trying to oppose each other. So when you need a greater flow of water, in electricity we would call it a greater flow of current. The wire has to be larger. Otherwise, a tremendous heating will take place due to the restriction of a small wire, or we could call it water-wise a small pipe. And if you try to force umpteen gallons of water through a tiny pipe, there has to be a tremendous force on the other end to push it through the tiny pipe. If it's a large pipe, it takes very little force to push the same amount of displacement of water through a given time period. Okay, now, when you get into a scalar signal that's sent down a wire, voltage and current flow in the same direction simultaneously. They're coherent with each other. Okay, if you're flowing at the speed of light coherently in the same direction, there's no way heating can be created. A wire can be the size of a person's human hair.
It usually is, though.
Exactly. Now, you can, your whole house could be wired up with number 40 wire rather than number 12.
If you could find it.
Exactly.
And Ron, tell him if you touch the two wires together, the machine just speeds away, right?
Exactly.
And you can hold those naked wires and nothing happens to your fingers.
So
Get
no little kid could stick his finger in the socket and get killed.
Exactly. Now, let me explain something. Approximately a little over a year ago, about a year and a half ago now, I was in John's lab over there, and he had fired off a 1,500-watt load with two pieces of number 42 wire off his generator.
Mm-hmm.
At first, I thought he was firing it off with one piece of wire. The other one was laying on a little piece of carpet. I couldn't see it because it wasn't too well lit at the time.
It's very small, smaller than your hair.
And he said, put your hand on this one, the one I could see, and I did. And I couldn't believe it. There's no way you can carry 1,500 watts through a piece of number 42 wire. And these wires were at least 3 to 4 feet long. And here was a quartz heating element glowing full bore. So John says, let me show you this one. And so he takes the two little wires off the end of the generator, connects them onto a normal AC plug, plugs them into a normal receptacle from the Edison company or whoever, and they immediately incinerated themselves. Okay?
Bad electricity.
Now, does that tell you what scalar is? Something is traveling in the same direction at an infinite velocity does not need a big pipe. Does that make sense?
Greg, did that help you?